I'm Craig Robson from Newcastle University, and I'll be giving a talk about a bit of reactive work that I did back in May last year in response to COVID and the introduction of social distancing policies. So, as I'm sure you're all aware, back in the UK, back in March, social distancing was introduced. The recommended distance of 2 metres from people outside your household. And obviously that has quite a big impact on how people interact and move around cities and travel. And obviously following the lockdown as well, obviously travel was reduced, but people were still allowed to exercise. So we looked at trying to develop a method to understand how easy it is for people to move around cities, be that for travel or for exercise, or for other purposes such as hospital appointments and similar. So we did a bit of analysis and attempted to develop a methodology that wasn't just possible to run locally, but we could run at a national scale as well. So, as I've said, when COVID hit the UK back in March, essential travel was only recommended, and the avoidance of using public transport was also encouraged. So in the chart on the screen there shows from March, when social distancing and lockdown restrictions were first imposed, how transport behaviour and use changed. So we can see back in March and April time in 2020, how rail use and bus use declined significantly, and then I can see how it's increased over time, and then again decreased again back in November when the UK entered a second lockdown. So obviously that also encouraged people to start using active travel methods. So that is walking, running, cycling, using scooters, to be able to make essential journeys or for exercise. So with that in mind, UK government encouraged councils and local authorities to make it easier for people in communities to use active travel methods to carry out your journeys. So in fact, the government made a pot of money available, and in the end, as of December 2020, it funded £175 million worth of projects. Just to put that into context, in August 2020, Highways England announced £27 billion worth of investment over the next 5 years for road projects. So it seems quite a big difference there. But these sort of investments were intended to make more space available for pedestrians and other non-motor vehicle road users. So that involves such things as modal filtering, as shown in the bottom image, where roads are closed to traffic but still allow cyclists, scooter users, wheelchair users, and pedestrians to access areas and use those roads. And other schemes as well involved, such as converting parking bays to cycle lanes and other similar sort of projects. And a lot of you may be familiar with similar schemes in your areas as well. Just to highlight how travel behaviour has also changed during COVID in the UK, this is actually data from the Department for Transport, which captures data on a daily basis since lockdown started, so going back to the beginning of 8th of March last year. And as you can see, so this is for cars, commercial vehicles, and national rail usage dropped off immediately during March and going into April, and has since sort of steadied out at sort of reduced levels in most cases, with the exception of heavy goods and cars, obviously people moving around, and delivery vehicles. But if you overlay on that chart the statistical data for cycle usage, we can see immediately that in April, May, and going into the summer in the UK, cycle usage peaked at nearly 400% the normal level on some days. You can see how that's evolved during the year and leveled out at still sort of over 100% of normal usage, and that's continued on through the UK winter. We can see it's just starting to rise again as we enter the spring in the UK, when warmer weather tends to make it more appropriate and more attractive to use cycling as a way of getting around. Just a quick slide on how people's behaviour has changed in terms of where they go and how they use city centre locations, for example. This slide shows a study in Manchester, which shows the recovery in terms of footfall around the Manchester city centre, shown in the middle of the map, and then the surrounding towns or suburbs. So you can see that as of December, the city centre of Manchester only had 30% footfall compared to pre-COVID levels, whereas the surrounding areas had a much greater increase back to maybe 50 or 60% of pre-COVID levels of footfall. And this is sort of called the donut effect, where major city centres have seen decreases in usage, but local shopping high streets and areas have seen people come back at a quicker rate. And this chart just shows how that's varied over time as well. So you can see with these areas how obviously footfall fell away during the initial lockdown, and it's since started to increase again as the UK has gradually come out of COVID and vaccine rollout has begun. And finally, just quick work on previous work before I get into the results of our analysis. One study was found in New York, which had done a similar analysis to look at pavement widths. So this image there shows the pavement data set and then the results of the analysis of pavements across Manhattan. I'll cover the methodology in the next slide because that's the similar methodology we employed. GISRUK UK, so this is maker of ArcGIS, they actually did a study about the same time as we did ours, and we both released our results about the same time, unbeknown to each other. But they use a slightly different approach where they use buffers. So they calculate the centre line of a polygon, which represents a pavement, and then use several polygons to buffers to figure out how wide the pavement is. And those results are both available online. So our methodology, as I say, was very similar to the one employed for New York, with a few adaptations because we don't have a similar data set to what the New York study had available. So to begin with, we use US mass map data. So this is Ordnance Survey data, which is a national mapping agency for the UK. We used their largest data set and most fine scale data set, which has polygons every feature in the UK. So using some previous research it did, we identified all the polygons that could be representative of pavement space. There's no single set of polygons that represent pavements. We have to combine a few different classes of features to form this data set. So we end up with something that looks like this, which is for a few streets in Newcastle, which shows the sort of polygons that we've identified as potentially being pavements or the most likely candidates for pavement space. We can then calculate the centre lines along those polygons of pavements. So this allows us to capture the features of the pavement. So not every pavement is straight and rectangle. There is potentially what you might see in that photo is islands in between parking bays where there might be trees and other sort of features. So this allows us to capture those. These sort of features may be missed by the method used by Esri, for example. So once you've done that, we can then calculate the width of the pavement by measuring the distance from the centre line to the boundary of the actual pavement polygon. And that allows us to form this complete data set of pavement widths across areas of cities and across the whole of UK. And then we output the centre lines or the actual polygons with the attributed widths as well. And all this is written in Python, which allows us to run it over large scale areas on high performance computing systems. So for an example, for Newcastle, which is a city of around 170,000 people, there's over 150,000 polygons. So if you scale it up to the UK, where there's over 350 local areas, you can see how we're dealing with quite a significant number of polygons where we've got to do analysis for. So going into the results for the last 10 minutes in the second half of the presentation. So this is the estimated widths across some selected cities across the UK. And when I say cities, these are defined as the local authority areas. So for example, for Manchester, that just captures the main central area of Manchester, doesn't capture those other suburbs, which I showed in the previous slide. So as you can see, for a lot of cities, the width of pavement is less than 2 meters for, say, 50% of the pavements. So this uses the length of the pavement as well. So this is a weighted calculation based on the length. It's not just purely a count of pavement polygons. So as you can see, 50% of polygons pavements are mostly less than 2 meters. For example, in a city like York, which is quite historic and quite well known for some of its narrow streets, over 60% of those streets were less than 2 meters, and obviously that makes it difficult to potentially socially distance when moving around those cities. Obviously, in the UK, the government also changed policy to a 1+ meter rule. So this outdoors, so this encouraged people to potentially only distance at 1 meter during the summer. And that actually obviously increased significantly the amount of pavement space that was actually suitable for people to use. So potentially these bottom parts of the graphs all then became suitable. So potentially opened up to 60% of more pavement space around UK cities to distance on. Obviously, that doesn't give us much of a spatial pattern of how that affects and can be applied in actual cities. So we made an interactive map where we can explore how that varies over cities. There's a link there. I won't go into that now, just for time reasons. But if you want to go visit that, that's openly accessible, and that has a data available for a few cities where you can explore the widths. So moving on to actually look at for a case study example where we can look at how it varies across the city. Use Newcastle examples. So Newcastle is a city in northeast England. It's quite an industrial past, so tends to be a lot of terraced houses which may feature narrow paths. So we've selected 4 areas. So A is the city centre, so obviously quite densely populated with shops, home to 2 universities and the main hospital, and also the East Coast Main Line train station, which connects the city to both London and Edinburgh directly, as well as many other major cities. The other 3 areas shown are all suburbs, so B, C, and D. So D and C are quite popular student areas that have quite a few facilities, such as bars and clubs and other facilities. And obviously, these 3 areas also feature a lot of schools and stuff, which I'll have a look at next. So if you look at these 3 areas individually, the city centre, the average pavement width across this area is 3.4 metres, whereas other areas, this is much closer, down to 2 metres and low as 1.6. And this is because city centre areas tend to have a lot of pedestrianised streets, a lot more open spaces around university campuses, for example. So the suggestion is there that the city centres tend to be quite easy to socially distance in, and the suburbs less easy. And as I showed in the previous slide, the suburbs and more local areas are where people tend to be returning to first, rather than the larger city centres. So having a look at slightly more detail, looking at so this is site B for Gosforth High Street, where we said the average pavement width was less than 2 metres. So this is a main high street. It's also, for this little suburb, it's also the main road and access to the city from the north. So as you can see, it's 4 lanes of traffic. There's roughly every minute about 10 cars in either direction. So it's quite a busy street. There's also quite a lot of buses use this road. There's quite a heavy traffic as well. It's not just small motor vehicles. In this location, it's a high street. There's lots of these black polygons show commercial properties, shops, takeaways, letting agencies, travel agencies, etc. The dots show facilities that even during lockdowns were available and people required access. So pharmacies, doctor surgeries, schools, supermarkets, for example. And you see in this area down the main road here, actually a lot of the pavements are maybe 2 to 3 metres wide. In some cases, it might be up to 4 metres wide. But obviously, it's a busy area with a lot of people accessing services. So in this case, decisions and interventions were made to widen those footpaths. So, for example, creating extra space, not just for pedestrians, but for cyclists as well, to make it safer for cyclists who are still travelling, commuting into the city centre, be able to do that safely. And also, for example, here the bus stop, so extending the pavement beyond the extent of the bus stop, so people queuing for buses, for example, aren't blocking the pavement for other pedestrians. And this is just highlighting the road there through the main sort of suburb area. Second case study here is in the Site C, which is on Chillingham Road. So this is a very popular student area, and it's also linked to the Coast Road, which is the main sort of connects quite a few large urban areas to Newcastle. So looking at this in more detail, again here we can see there's quite a few commercial properties here, and the pavements actually here are quite wide, over 4 metres. But up at the northern end of the street, up here we've got a school, we've got other doctors, and there's also a veterinary practice as well, although it's not shown. So obviously at the northern end, the pavements aren't actually wide. But if we look at the council's intervention plan to attempt to make it easier to social distance, the intervention plan actually only covers this bottom bit where all the commercial properties are, where shops and takeaways, etc., that we're still operating. It doesn't cover the northern end where we have a school, a church, a veterinary practice. These sort of interventions including blocking off roads to make it safer, increasing pavement width, closing off parking bays as well. And just a final look at the city centre in Newcastle. So obviously the city centre, as I said earlier, it's quite a busy place normally with a lot of shops, 2 universities, a hospital, so also quite a lot of office space. There's also the main route down to the quayside, which is quite a popular recreational area for people walking and meeting up. So if you look at this detailed map of the city centre, we've got the 2 universities at the northern end of the city centre. We've got a hospital in the northern part as well. We have the main shopping area in the centre of the area. And at the south, we've got the train station and this road here, which is Grey Street, which is the main access road down to the quayside for both pedestrians and traffic. And Grey Street's also been voted one of the most, nicest streets in the UK due to its Georgian architecture. So the city have planned to remove a lot of the parking and introduce cycle lanes, which you can see here. And they've also increased the amount of pavement space that can be used for cafes and such, which feature on the street quite prominently, as shown here as well. So with a minute and a half to go, I think. Data awareness. So pavements have multiple uses. So in this example, we've just looked at the polygons that we have access to. This doesn't include information on how those pavements might actually be used. So I've said, benches, cycling space, bus stops, pavement cafes aren't captured in this data set. So we can't actually, pavement might be 4 metres wide, but 3 metres of that might be taken up by pavement cafes. So actually it's not that suitable for social distancing. And in Newcastle itself, for the opening up of pubs and cafes, I think there's over 40 new places have had permission to open up pavements, convert pavement space outside their premises for outdoor dining, etc., which often limits people's ability to move around. And just to highlight other issues with the data itself, for example, here, because there's an overpass, we don't actually have the width of the pavement around the area. Here is a bridge. Pavement data is missing on this bridge as well. Here, for example, how do we cycle path data where shared use isn't included in the data we have? How do we incorporate that? And then also here, paths on the central motorway. This is, it's a 4-lane motorway. How do we, apparently there's a path along there just through the nature of the data classifications. So conclusions, future work. Obviously, we've hoped to show that we can do this national scale analysis and we can examine how the data looks and how wide pavements are. But does that reflect necessarily how people use pavements, and how do we better inform policy using these sort of data sets? How can we, councils, provide safer space for people to use going forward, especially given the tendency for a new focus on local shopping services rather than city centres? And with that, I'll end it there. Thank you, everyone. If you've got any questions, please do ask.
And this is from Malcolm, who asked, did you compare your results against other tools like Widen My Path and Rapid CPT that looked for places where road space could be reallocated to walking and cycling?
In short, no. I haven't heard of that tool that's mentioned. That would be interesting to look at that. And see, there's posted a link there, so maybe I'll have a look at that. And yeah, we've not come across those previous bits of work, but certainly would be interesting to see how we can incorporate them going forwards. Obviously, social distancing seems to be in place for quite a time yet, so it'd be useful to actually look at that and see how that can inform better the analysis we're undertaking. So yeah, thank you, Malcolm, for sending those links. Certainly take a look.
We have two questions. One's from Nick. Thanks, Craig. Great presentation. Could you say a little bit more about how you access and process the master map data in the first stage of your methods? You mentioned NISMOD-DB API. What is this, and how did accessing the data work?
Yeah, okay. So the master map data, we use a Python script. So that was originally, we sort of adopted the methods from the New York study, which was freely available on GitHub, where we extract the polygons and then we generate a center line and then split that center line, which is obviously into its individual line segments. And that allows us to then be able to calculate the widths from that center line and those individual line segments to the boundary edges of the polygons. I hope that maybe helps Nick understand that. And the second part, NISMOD-DB API is a database and API which we set up as part of another project called ITRC, which is looking at infrastructure future for investment planning. So that is something I set up. So that contains a lot of infrastructure related data, including master maps. So that just gave me access and the ability to download for a particular local authority area, or even just a single postcode, just the data we were interested in, rather than having directly downloaded from Ordnance Survey. And because of the previous research, we were given the Ordnance Survey data for the whole of the UK. So that was just a way of automating the whole process using the previous work we've done.
And then there's a question from Jonathan. Have you considered the implications of this beyond COVID? I suspect this could be really useful in photo wheelchair users where less than 1 meter is unusable, and possibly pram users too.
Yeah, that's a really good point. And it certainly would be useful for wheelchair users, as well as also cyclists. Obviously, we've looked at the ability to social distance and how wide roads are. So if you've got a narrow road, it's also not particularly safe for cyclists potentially. But yeah, so wheelchair accessibility is quite a big issue, especially in maybe historic areas where you've got narrow pavements as well. So yeah, that's a good point. And yeah, that would be something interesting to look at and see whether we could also maybe incorporate height data into that. So look at the slope of pavement as well to consider how actually usable they are, not just in terms of width, but whether they would actually be able to negotiate those pavements.
And then finally, there's a question here. Do you have a plan for making your algorithm codes and data open source?
So the code is on GitHub. And I think it's available. I'd have to double check whether I've made it public, and there's probably some documentation that we need to go along with that. But yeah, the code, our adapted code from the previous New York study should be available. And the data, because it's derived from OS data, there's a few potential issues there. But I think my understanding is that we could share the centerline data, for example, because it's not directly actual OS data. But yeah, so we could share that. And as I said, there's an online map where the data isn't obviously downloadable, but it is viewable. Yeah.